Hello and welcome back to the Subdividing Studios YouTube channel. In today's video, we're going to be taking a look at how to model more complex shapes, particularly looking at curved shapes which have hard angles as well, because I know that can be really difficult for beginners. It was definitely very hard for me when I first started. I ended up having to learn myself because yes, there is some information out there on this, but it's sort of few and far between. So I'm going to be going sort of more conversationally rather than tutorial-esque. Looking at some of the models I've made, explaining why I did it the way I did it, and how to also achieve the same effects. So I'm hoping by the end of this video, you will come into making more complex models with a bit more confidence, and it's going to dispel some of the sort of like mysticism maybe around these, and make it easier for you to approach them for your own projects. And remove some of that anxiety if you want to make something really cool. So one of the main things that I would mention is that you should break things down into smaller tasks. Like with any kind of large goal or task in life, it's so much easier to tackle that task if you actually break down what is a complex problem into smaller shapes, smaller parts, and keep it as simple as possible for as long as possible. And we can apply that same technique to our 3D work as well. So what that means specifically for 3D models like this guy here, this helmet, is that we'll be starting out with simple shapes and keep them as low poly for as long as possible. And I've got a few other models in here as well that I can show you that are also good examples here. So if you look at this, while it might look like on the surface it has a lot of detail, we can kind of break this down into a few simple shapes, and that's exactly how I went ahead and did it as well. And what this phase is called is the blockings phase. So that we know we need to make this shape. So how can we do this? Well, if you look at the capsule here, this is largely just a cylinder. Yes, it has all these extra insets, but you can add those afterwards. So you could literally start just by creating a cylinder, and the primitive shape will depend based on what your final model is going to look like. If it was a bit more angular, you might start with a cube. If it was a lot more flat or a panel, you might start with a plane. But you get the idea. You just want to start with an incredibly simple shape to begin with, and then work that up from there. So all I really did to create something like this is I start with a cylinder, okay, and then we just start modifying it very subtly to begin with. We're just adjusting the scale, and then maybe we'll move this back like this. Okay, so if we take that to the side, that's the basic shape already of our capsule here. And then what you would do next, and again, this is sort of simplifying things, and it's obviously going to depend on the model. But for this is exactly how I went about doing it. Let's say that we're now happy with this shape. We know we want this to be the shape of our capsule. You can see, like we did when we created it, it matches the shape 1-to-1, except for all the details. Well, what we can go ahead and then do is, we don't need these faces here, so I'm going to go ahead and get rid of them, these two caps. You might need to keep those, but again, it all depends. And then literally all we're going to do is just go ahead and then subdivide this. And the reason why we're subdividing this is because once we're happy with blocking out the mesh, we can then go ahead and add more divisions. And you might be wondering, well, why do we need more divisions? Okay, if I just undo that subdivision. When you look at this, the topology on this, the mesh density is really high compared to just this normal cylinder. This maybe has something like 20 spans going around, whereas this, you know, I'm not going to start counting them, we'll be here all day, but if I were to select all of these, you can see these kind of vary in density. These ones are still denser than this base mesh that we made, but are not quite as dense as this one up here. And the reason for that is because, well, we need to cut in a lot more details here. We've got this shape for the windows to look out. We've got these windows here. We've got these little circular elements as well. And that's quite a lot of detail to cut in, and you might not be able to do that as easily on a shape like this. So something to consider when you're finished doing your base mesh and you're starting to subdivide is how many times you actually want to subdivide this mesh. Have a look at your reference, which is really important, and check what kind of details you have on your reference. If you're looking at it and you see that you just have more details like this, these kind of large scale doors, these bigger panels like this, then maybe you won't need as much topological or mesh density, right? We can keep it a bit more simple like this. But if you're going to have lots of small little details, like up here where we've got this big hole, we've got a square, we've got this kind of non-uniform, slanted sort of square, or not square, rectangular shape here, and some circular shapes as well, you might need more density. So it's really going to depend on what you're going to add to this afterwards. But the core principle is start as simple as possible, right? Like we did with that cylinder earlier, okay? You just scale it up to match whatever reference you're modeling from. Maybe you're just doing it by eye, you've got some reference on your other screen or something like that. Maybe you've got some blueprints in here and you're matching to those from a few different angles. Whatever it may be, start as simple as possible and keep it that way for as long as possible. I would also say that it's a good idea to model something as one mesh. You may have noticed already that this is all separated into individual panels, but trying to do this individually would just be a nightmare. You'd never be able to get things to line up correctly. And even if you did, it would take you so much longer and the result probably wouldn't be as clean as opposed to modeling it as one single mesh and then cutting parts out afterwards. I think that's where a lot of beginners go wrong, is that they try to kind of break this down into individual parts first when they're modeling something. You know, you really don't want to be getting that granular straight away. If you imagine it kind of like a Russian nesting doll almost, with kind of an odd analogy, you want to start big and then go smaller and smaller and smaller and smaller until you're done. If that makes sense, and it will just make it so much easier for you. So let's say that this is the density that we wanted. Well, what we could do now then is, you know, I'll go ahead and remove some of these edge loops because we might not necessarily want all of these. Let's say we want to create this panel here that's on the front. Well, then literally all you would do is just add in an edge loop, and then we can go ahead and just edit mesh and then extract this off. Okay, so now we have that as a separate panel, and the edge flow is more matching, which is good for us. We like consistent topology. It's going to make it easier for you to work on all the way down the line to texture and render, and of course for modeling as well, most importantly. And also the lines also match up as well. If you try to model these separately, you know, you might end up with one part like slightly not matching, or just the angle being a little bit different. It just wouldn't work as cleanly, you know. And then we could then maybe go ahead and start, maybe we want to cut out this panel here. So we go ahead and separate that as well. And again, that still follows the curvature because we made it as a single piece. So then what if we wanted to go now and start cutting in more of these cylindrical detail, or circular details, sorry. Well, maybe we'd go ahead and subdivide this again. And there's absolutely no problem with this part having slightly more density than this part. In theory, you know, sometimes it does make more sense to keep the topological density the same. Okay, the mesh density the same. But oftentimes it also really doesn't matter too much. It kind of depends what you're making this for. If this is for VFX or just for concept art, then it's really not that big of a deal. And sometimes you need a difference in mesh density as well to be able to achieve what you want to achieve. So then maybe now we could go ahead and put some edge loops in here. And maybe we want a circle in here as well. So we'll go ahead and just do an extrude, give that a bit of an offset, and then we'll just use the circularize. Okay, and because we have a lot more mesh density there, if we go ahead and subdivide that, you can see we're not really getting any weirdness. Okay, there's no artifacts. If we were to take, let's say, this cylinder again, and we wanted to cut in a hole this size on this mesh, okay, if we were to go ahead and try and do that, you can see you're going to start to have problems because look, we've got to put all these extra edges in. We could then go ahead and maybe do the same thing. But if I subdivide that now, you can see we're getting all this nasty lumpiness, okay? It's because the mesh is not there to support it. We don't have enough density for the smaller details. Something else as well that I think is really important to mention is that when you want to add panels like this on this Orion capsule here, instead of trying to cut these into a mesh, right? So maybe you might be inclined to use the multi-cut tool. You know, you could do it this way. Maybe you might want to do something like this, okay? You want this sort of panel, right? That's not the cleanest, but you get the idea. Some people might be inclined to go ahead and bevel this. And then extrude in. Okay, and that can work, right? That's not necessarily the worst thing in the world to do. And then there are times when, whatever you're modeling, you know, and it's always a good idea to make sure that it matches what you're modeling in real life. So if in the real model it has something like this, probably a good idea to match it too, okay? Especially, you know, if it's one piece, model it as one piece. If it's multiple pieces, maybe model it as one piece and separate it afterwards. But generally, if you want to do a panel line, especially if it's a really small one like this, where things are really, really close together, right? Like obviously this is a spaceship, so you don't want massive gaps between things like this, right? Then it's better just to actually, instead of doing that, instead of beveling that edge, just separate those faces like we did earlier. Come back up to edit mesh and go to extract. So now we have that as a separate panel. Okay, and then the reason why we're still getting these nice panel lines is because we've gone ahead and added bevels in afterwards so that we're getting that shading there. And it just looks like a really, really tight panel line rather than a big gap. Now, if there is supposed to be a big gap, like I said, you can go ahead and model that in, that's okay. But the core principle that I'm trying to sort of relay here is that you start simple, okay? Like we did with this cylinder. We adjusted it to the shape of the capsule. And then once we were happy with it, we went ahead and subdivided, okay? And then we can start going in and cutting in more details like these holes here, all right? If for whatever reason you wanted to keep the caps on these cylinders and you still want to subdivide, instead of beveling this edge, okay, and then subdividing, which will work, but then you're going to get a bunch more edges, right? Because it's going to add more edges in between. That's how subdivide works. What you can do is select the edges you want to keep hard, use the crease tool to keep those solid. So then that kind of just tells Maya you don't want to subdivide those edges. Okay, you want to keep those hard when you subdivide rather than it collapsing, sorry, when you smooth. And now you don't have all this extra geometry, but you have it in the areas that you wanted it, just not in the areas you didn't want it. So that is also another tool you can use when you're happy with your blocking. If you want to maintain hard edges and just add some more mesh density, you can use the creasing tool to hold those temporarily until you add bevels later. And this will work for essentially anything that you're working on, really. I used it for this Orion spacecraft capsule here. This is all broken up into tiny little panels. I don't know whether this is actually accurate to the real model now. I built this, or the real ship, sorry. I built this like 5 or so years ago, well before this ever actually flew. But you can see this is all separate panels, and I built this as one piece. I have this model here as well that I made some time ago. And again, this looks complex, right? We've got all these extra little bits cutting in. You know, this is one piece here. But what you've got to realize is this all just started from a cylinder. Or a lot of it anyway. Just a cylinder, shape it to how you want it, you know, and what I would advise is spend as much time as you can in the blocking stage, because it's going to save you so much headache later. If you match all the proportions of your reference 100% or as accurately as possible, then you're going to have a much, much, much easier time later on, okay? Again, if we wanted this to be part of the fuselage, you know, we would literally just, once we're happy blocking that in, obviously this is just a tiny little part of it, right? Something like this, get the idea. But let's say we were happy with that, we could then just go ahead and start smoothing to add the density that we need, so we can start adding in details like these panels at the top here, right? Because if we kept this really, really simple, we just wouldn't be able to do that. So again, really, it's all about starting simple, keep it as simple for as long as possible. Then once you're happy with the final shape, then subdivide and go and start adding details. So we'll just come back to the helmet example that we started with to begin with. And again, you can see here, I'm adding density where I need it. On this faceplate here, we obviously needed to add in a bunch of these little circles. These circle hole punches, these breathing holes, we wouldn't be able to do that if the density was more something like this, because we want to maintain that smooth surface, but we need the correct number of edges to do that. If we don't have the edges to add these in, it's just going to be an uphill battle and it's not worth it. Okay, it's just going to make a mesh look clean, untidy, lumpy, and you're going to get a lot of artifacts when you go ahead and do smooth those things. But you can see in areas where I don't need the density, I haven't added it. Okay, so it's just about thinking about where you're going to have details and planning ahead. And when I first built this was all really, really simple. It was even lower res than this. Essentially, I just started with a cylinder. You know, just to show you another example here, scale it up. Delete these bottom faces, obviously, because it's a helmet, not like some kind of solid block. And then just remove some of the faces that I don't need. Okay, so there you go. That's sort of the basic shape already. And this could work. We could then go ahead and crease these edges here so we can smooth this to add more density. Or alternatively, before we even do this, you know, we could think, well, I know that these two parts are going to be attached for the time being, even though I'm going to separate them later. So why not just add that density in to begin with? And then go ahead and delete the faces that I don't need. Right? Like so. And then now we know this lines up, then we could go ahead and separate this. Okay, but everything still lines up nicely, and we can start modifying things as we need to. You know, maybe we want to add this kind of visor line here. Okay. Right. You get the idea. Okay. So start simple, subdivide when you need to, then modify. One last little thing I want to mention as well when you're working on shapes like this is a lot of times I see people struggle with hard corners on smoothed, curved surfaces like this, and it can be really, really tricky. And oftentimes what I'll see when people do this is they might try and do something like this, which on paper looks okay. You know, they've got an edge coming into here, an edge coming into here, so that should hold that when we subdivide and smooth. But this edge here going diagonal is not always the best thing to have. It's okay sometimes, right? Because I have that here on this faceplate, and it will work for these circles. But on hard corners like this, big corners, it's not always going to work very well. And if you see, as I just move my camera around here, you might not be able to see it too well on YouTube. It's a little faint, but it is noticeable. We're going to just kind of pinching in the corner. And this is pretty a minor case of this, but it can be a lot worse depending on, you know, if the mesh density here wasn't as high, if we had less edge loops, it would probably be even more noticeable. So that's just something to keep an eye on when you're doing something like this. It's normally better just to redirect some edges. So that's what I've done here. I've literally just slid these down. What you can do is come to the modeling toolkit, go to transform constraint and turn on edge slide, and then that now allows you to slide these up and down. You can see it's not modifying the shape. If I was to turn that off, you can see it's making that go in and out, right? Because it's off axis. But if we turn on the edge slide, it doesn't anymore. But the main point being, I'm just redirecting some of these edges already. It's not harming the flow of the topology. It's still going roughly in the same direction. It's just a little redirected. And because we have a nice mesh density around it to support this, we're not getting any of that weird pinching, right? Again, you might not be able to see that on YouTube, but I promise you it is there, or in this case, it's not there. So that's just a few pointers on how to work on more complex models. I hope that's been helpful. It's kind of hard to explain, perhaps, over a single YouTube video, but really it's not a simple thing to do, I know. Even if you do, if I make it look easy, it's definitely not easy if you're not used to doing it. But it's one of the things where practice makes perfect, and don't be afraid to make mistakes, because you're going to make mistakes. I make mistakes, okay? I've been doing this for 10 years. I still make mistakes. Just today when I was making this helmet this morning, I had to restart because I couldn't get this visor shape to work properly, and it was getting a bit weird, right? And this is a lot simpler than, say, something like this. But this plane took me an incredibly long time to figure out how to get all this topology correct, to do what I needed it to do. But in doing those, you learn and you get better at it, and you know what to do next time, like with anything in life. But the main point of this video is to make complex shapes, just break it down into simple shapes, subdivide, then add detail, okay? Don't do it in reverse. So I hope you've enjoyed this video. If you have any questions, or if you'd like me to make another video expanding on this topic, or even if you'd like to send in some of your models that you might be struggling with, or just even some reference that you've picked up and maybe you want to model that and you want to know how I'd go about doing it, please don't hesitate to let us know. Like I said, there's an email link in the description if you want to contact us directly, or just leave a comment under the video. Thank you very much for watching. Like and subscribe, and yeah, good luck with your projects, and I'll see you in the next one. Bye-bye.